Awesome. Thank you very much for coming out today and, getting to hear a little bit about securing the software. Let me do a couple of really quick introductions. We've got a really great panel today for you guys. Mrudul Uchil is the India site leader and senior director for cybersecurity for Visa. She has an incredibly deep background in design and architecture of products covering identity access management, security, cloud, mobile infrastructure, with products in the SaaS and PaaS offerings. To my right, I also have Harish Goel, who's the director of IT security and compliance for our Publicis Groupe. And it's a huge global organization. He leads the IT SOC, NOC, and security initiatives and responsible for securing the organization's environment for internal and external attacks and breaches. A very serious job. And Abhishek Datta is the senior engineering manager over at ChargeBee, leading multiple teams in development of identity access management platform, microservices framework security, and DevSecOps initiatives. And of course, me, Matthew Bohne. I'm the VP and Chief Product Security Officer at Honeywell. I lead a team of global cybersecurity experts who spend their day and nights, protecting the software that we make. So our panel today brings together, a lot of key industry leaders to discuss the challenges of best practices for developing software securely, right? It's not a trivial exercise, and it is quite different than perhaps, what most people see as sort of IT security or OT security. And, hopefully everybody's going to be able to walk away from today's discussion with some insights on how maybe they can enhance their own sustainable, secure software development lifecycle. So, with that, let's jump right in. So, Harish, why is software security so important?
Okay, so we all live in a digital era right now. So we all know, software is used everywhere. So everything is software driven right now. So the shoes we wear and the system we use and the IoTs, everything is a software. So security is must, it is a need of the hour for the software. It is not an option anymore. So let's take an example we have a kids in our homes. So we teach them, we train them before we send them out of the home. So same way softwares, we have to secure them once we are developing before putting them into the productions. So this is very important that yes, software security is nowadays is very important for every organization.
Great point. So, Mrudul, for software companies, which comes first? Security or the software?
Hi, Matt. I think my voice is loud. Okay, is this better, guys? Okay. So first of all, good afternoon, everyone. Very happy to see so much overwhelming participation, not just this session, but I think overall Nullcon. So thank you so much. Hopefully this is a session where you will be all awake after lunch. So to answer your question, between software and security, in my opinion, both go very hand in hand. Both entities are required. They are integral part of the system. And why so? Because today, in today's era, cyber attacks are increasing all the time. And exploiting the security vulnerability in any software has become the very significant target for all hackers. Because once you exploit any software, all the users of the software, applications that consume the software, everything, it goes in the exponential attack. It's like a catastrophic. And in that range, it can exploit right from changing a device to bot to a DDoS or a CVE. And that's the reason security is integral part of the software. You cannot separate both. Now coming back to your SDLC question. So SDLC has been there ever since software is there. But I just want to connect the thread to our keynote topic, which was very good. Learning from past, acting in present, and going for future. How do you prepare yourself, right? So going from reactive to proactive approach. So even same the case should be for SDLC. Our SDLC should evolve to the next gen. And it should be right from requirement to your deployment. So when you start designing, architecting your product, right there, threat model, look at the attack surface, what is your ingress, egress, and what could be the attack surface open. That is first. Then when you write code, secure coding guidelines is very important. I'm going to take quick 3 examples, which came in the keynote, very easy, but very important. Input data validation or sanitization. Then for cross-site scripting, right? It's very easy to set cookies, same-site cookies. Very simple things, but I think that should be in the mindset when you write the code itself. And the SQLi, which is very, popular vulnerability. So never write queries which is exposing data right from your DB. Always use stored procedures or, wrappers. So things like that. So when you write code in that way, that is taking your mind to the security or, not even creating vulnerabilities. Forget about fixing it. Now coming to the next event of SDLC, which is your SAST and DAST, utilize all the industry leading tools. I think we have many, Checkmarks, Codacy or Micro Focus, Synopsys. So always use those tools which are proven in industry, and also focus on things which are not done in the past. Things like when you use tools, there are a lot of false positives and there are no recommendations given how to fix it. So work on things where you can customize those tools. Don't just use the tools. Now Checkmarks gives a lot of ability to customize it. You can customize, write queries so that you can reduce the false positives. So those things like that. Even DAST, when you use DAST, don't just keep to the stage where you're writing the DAST queries or simulation and then not looking at the industry, what is changing. So continuous evolution. And the last one is open source scan and the third party scan, which we use Veracode. So this is the entire life cycle which you should implement. At every stage of the SDLC, there has to be security practices implementation.
Great point. So it's understanding that it's through the whole life cycle and using your tool chain effectively and correctly through that whole life cycle. So I got a question for everybody. So we often think about, building secure applications, and, we all have sort of our own little bit of recipes, our own little tricks. What are your top 1 or 2 application security best practices? What's your recipe? Why don't you start off with Abhishek? Or
Go ahead. From my point of view, one is the most important about the privilege access. Like we should have a limit access. I'm not saying, we should restrict the access to the developers on the repositories, online repositories and the stuff, but we should have some kind of a limit access so that we can prevent some kind of attacks here. And second is about the continuous efforts in terms of the code, what we are writing, the developers are writing for the analysis of the codes and the testing. Because right now, we are into the CI/CD pipelines, we use it. So that continuous efforts of analysis and testing is more important. So these are the 2 things I can say, and I want other panelists to add on.
Okay, I'll quickly add on it. So just extension to SDLC. I think you should have a very mature security assessment pipeline in terms of making sure all key controls are scanned. And we comply as a cybersecurity program or a company, you comply to a lot of standards like NIST and so on. So make sure right from architecture, SSDLC, your ethical hacking or mobile and bug bounty, white hat. So there are so many key controls that you should scan. And nowadays, again, the change should happen, right? There shouldn't be only scanning. There should be automation. So all this scanning, the workflow should be automated, integrated, good enough. And the last one I want to mention is the cloud strategy. Quickly, I think we have a separate question on that as well. But depending upon your workload and payload in the company, sensitivity of the transaction, criticality of the security, you should decide on the hybrid model versus public or private. What goes in public, what stays in private, depends on your company security strategies and the business that you are in. Let's say for fintech, when you handle a lot of PI information, you cannot have all your workload in the public cloud. Because though everybody knows about the advantages of the public cloud, there are still things to be worked upon in terms of security, control, logging. And since cloud is known to everyone, it is prone to DDoS more than your private one. So I think things like that should be part of your recipe.
So what was the question again? What are the tips and tricks for
what are the top application security best practices from your experience?
Okay. So I'll probably talk a bit on maybe on the engineering side of things. Just like if you're managing infrastructure, you would probably not want your secrets to be spread across different people in the organization, right? So if you're a security architect, how about think of not, spreading across security validation, like input validation across every single developer. How about build systems which will automatically validate input before the business logic is invoked, right? So you will have one single place for your security team to audit that all the validations are defined or not. If it is not defined, it is validation. As a security team, you don't have to look at 100 different applications. You will just look at one place. You will see that input validation is there. I'll give an example like what I have seen in real life, right? What a lot of organizations follow. See, for example, if you're an organization which has recently or maybe in the past adopted API first development, right? You define specs, maybe API specs, or for any kind of software engineering, you will probably start with specs. How about adopt defining validation criteria as part of the specs itself and generate code with input validation baked into it? Like, I'll give you an example. You can have, if you use OpenAPI as the specification for defining your APIs, you can have OpenAPI annotations to define input validation at your spec level. And from there, when you generate the code, that code by default implements all kind of input validation that you have defined in the spec. So imagine what happens, the benefit. You, from a security perspective, you don't need to go and look into 100 different source code to see whether the input validations are done correctly or not. You look at the spec, you see input validation constraints are defined. All the validators are at a single source of truth. The validation logic is generated. So you can have trust from your security architecture perspective that input validation will be performed. So this is just one aspect of it. So the overall point is that why not build systems that are inherently secure so that the security decisions and security logic is not spread across various parts of the code or the infrastructure.
Great point. And I'll just close that comment up with one of the things that I find that's a real easy takeaway is as you build your programs, create simple minimum requirements for all that all software must perform, right? Start with a minimum set of things that you want. We were talking about the SDLC, talking about threat modeling and open source scanning. Put it in simple enough terms, English terms that your leadership will understand. And if you create minimums that anyone can understand, your 16-year-old daughter can understand, then it makes it super easy to get buy-in from leadership. Because when people don't perform them, people ask questions. But if you leave it in a technical jargon in your minimums and your articulation of how the minimums are done, then it makes it very hard for leaders who you're really the people you want to enforce these things on the development community. They won't understand them, or they'll need additional understanding or additional education. But by simply using simple terms, clarifying what your minimums are, and then ubiquitously rolling it out across your entire organization, it becomes much easier to consume and apply. So, moving on to their next question. So, Abhishek, securing cloud has been a real struggle. I mean, we heard today at a number of sessions around cloud. Yesterday, there were some great discussions about cloud. What are the top 3 mistakes you see that developers make, and how do you combat them?
Okay. So from my perspective, what I have seen, one of the biggest mistake is, not managing secrets or privileged access in the cloud properly. But I'll probably break it down into a bit more generic based on my experience. So what I have seen is that if you're starting a new company or if you're adopting cloud, many times what happens is that you start with probably a few cloud accounts which are meant for your production and non-prod use. And then you end up creating a whole bunch of accounts for, say, testing purpose, for POC environments, for different teams, right? Then later, when you revisit and you see that you want to probably have a cloud governance and cloud security program implemented, you suddenly have multiple cloud accounts laying around here and there, and you don't know what to do about it, right? So then you have to probably get them towards organization, adopt in AWS language, service control policies, adopt policies across. So first point is, from my perspective, bringing this account governance is probably the fundamentals of getting started with a public cloud, right? Subsequently, as most of us have seen, traditional vulnerabilities will not be relevant for cloud managed services. For example, consider AWS ALB. Even though AWS ALB was probably vulnerable to this desync, HTTP desync attack, but general NGINX vulnerabilities or exploits will probably not work against ALB, right? But many a times the most common vulnerabilities or flaws that we see in the cloud is misconfiguration. Not being able to leverage the identity and access management capability provided by the PaaS, the cloud platform itself, effectively. Even I have also made the mistake, like for example, even for Null community, many of you may know that we host some part of Null websites in AWS. We had created, initially days, we have created policies with lots of needless permissions attached, right? So these are some of the problems that we need to look at, that whenever you follow principle of least privilege, whenever you provision or use any kind of cloud resources, as a security architect or security professional, have very good understanding of the identity and access management capability of the underlying platform and see how we can enforce principle of least privilege whenever you are adopting any services. And third, again, as I mentioned, secrets management. How do you handle that? Right? So you need to have POC accounts for your developers. You need to give access to various cloud environments to your developers. How do you provision that? For production or other environments, how do you provide access to various application, to various resources, right? Follow IMDS or instance-based permissions. Don't provide a secret access, provision credentials, use the capabilities of the cloud for provisioning access. I would say these are some of the best practices.
Great points. Excellent. So I want to sort of shift gears a little bit. And, we've heard so many challenges over the last, especially in the last 12, 18 months about, securing software and the issues that come with attacks coming from supply chain and other areas. How should companies protect the integrity of their development environments? I want everybody, but Mrudul, go ahead. Why don't you start us off?
Okay, so I think everybody has heard about zero trust architecture. It's not an architecture. So to answer your question, Matt, what every company should do to have the integrity of their dev environment, I think this is the time where everybody has to jump onto zero trust philosophy. I think last 2 years of pandemic has taught us that we cannot trust any external versus internal network as such. So I'll just little bit go over the building blocks of zero trust philosophy. And again, it's a philosophy. It's not one single architecture or technology. Right from, earlier we used to first trust and then verify. Now first we verify and we trust. So that is the first foundational principle for zero trust. You trust no one unless you verify. And every network is hostile. That is what that has taught us. There is nothing like internal network is secure and external network is not secure, because both networks are prone for attacks and hacks. You authenticate every entity, every user, network, device that is interacting with the system. So that is where you verify each and every entity. Authentication, I think IAM technologies have evolved too, starting with least privilege or just-in-time privilege. So you give access rights or privilege just for the task that you're doing and just for the time that you want to do that task. So JIT and least privilege are coming into picture. Again, fine-grain authorization. So give very, very fine-grain authorization to each entity in the system, right from network to infra to app.
So for the developers.
For the developers, yes, for the developers.
Okay.
Because right, as there is a study that more than 50% of attacks are internal attacks, insider threats. So, yep, that. And then there is a continuous security efficiency, which is also part of zero trust. Now, you must have heard about the behavioral patterns, right? So every time you see an incident, every time there is an attack or threat, we talked about threat intel. I think there was one session. So there has to be a closed feedback loop from that to learn, that behavioral pattern and feed that back into the system so that system becomes efficient every time the incident happens or attack happens. So that continuous efficiency has to be there. Then secure logging, monitoring. Yeah, because that's part of the zero trust too.
Yeah.
So I think there are many building blocks as such, and that should be the philosophy for everybody to, as every organization to actually have for the integrity of their dev environments.
Great. Harish, what do you think?
From my point of view, the most important is the auditing part, which Mrudul has mentioned about it. Like auditing is most important because you track your changes. So developers do a lot of changes in the environment. Might be they are using the on-prem on the online repositories to push their codes. So you know what changes they are doing, what versions they are using, and if in case of any problem or in case of any incident, you want to track back. Yes, you have all the auditing in place. So auditing is most important, and we have a lot of proactively tools in the market which can do the proactively monitoring of and which can maintain the integrity of the software as well. So Black Duck is one of the tool which is there in the market. Similar like there's so many others there. So these are the two stuff. If you'll maintain, then it's easy. You guys to maintain the integrity, and damn sure you can take it out.
Awesome. Abhishek, go ahead.
Yeah, I'll probably be a bit more specific. So if you see after this, what is it, where this Microsoft FireEye got compromised because of SolarWinds, right? So everyone has started talking about supply chain security. It's actually very big. It's not just about libraries, bunch of things are there. But if you look at this OpenSSF initiative, Open Source Security Foundation initiative, they are actively trying to solve this problem, this major problem. This is a very difficult problem actually. It's not just about running SCA tools or knowing about third-party vulnerabilities. It's much bigger than that. One of the things which OpenSSF is trying to solve is ensuring the integrity of software starting from source till it gets deployed and operated in an environment, right? Ultimately, you want your infrastructure, your environment where your applications are running to be trusted, right? You want to know what is running is the exact same code which is built or not, right? There has been cases in the past where, say, you have your secure source code control repository, but your CI/CD is compromised. CI/CD is not protected. Jenkins, for example, Jenkins is well known that if someone gets a user account in Jenkins, there is a high chance they will submit a malicious job and gain access to the CI/CD environment itself, right? So as part of this OpenSSF initiative, multiple tools are built in order to generate manifest of every single build artifact, cryptographically sign those build artifact, generate provenance, what is called provenance, right? So at the time of infrastructure provisioning, deploying these applications into a particular infrastructure, you can verify whether the artifact that you are deploying is actually the artifact which was built by a trusted build system or not, right? So maybe you can look at this set of tools. There is also a framework called the SLS, what is called the SALSA framework, right? Which actively talks about the best practices and the tooling that you should adopt in order to harden your application software supply chain.
Great point. So for those, SALSA framework is something that you definitely should take a look at if you're not familiar with it. So let's get into the next question. Harish, so a lot of DevOps teams struggle with security. What kind of lessons can you share with implementing, DevSecOps?
Yeah, recently we have so many lessons there. We all measured, most of us know about the Log4j vulnerabilities and the Spring4 shell. So these kind of vulnerabilities are there in the market. So let's just go into the deep dive into the Log4j. So what was that? It's just the basic old vulnerability which was exploited by someone and put it on the cloud. And then it becomes a nightmare for all the cybersecurity defense professionals. So that's the great lesson for all those organizations which is still following the old methodology of DevOps. They are just trying to adopting, or they are into the phase. Okay, they are thinking that they will do it. They will add the security into their DevOps part, but they are not. So they have to think in that way. Okay, they can add it. They can learn those lessons so that history should not be repeated, and we should not have these kind of things. Because what happens that when you don't have the security in the development phase, so you are putting not your organizations, you are putting all those organizations which is going to use that software in the market later once into the production. So it is a very huge effort for all those organizations, because Log4j, like thousands of applications was compromised. Nobody knows, okay, where that application is that, what module they have to patch it or fix it. And they have a lot of legacy also, because it was an old vulnerability exploited. They have a lot of dependency. So they can't fix it over the night. And still, till now also, there are the organizations which are still fixing out, trying to find out the alternative and workarounds. Okay, they have to work on the Log4j or they have to fix it out. So it's a lesson definitely for all of us and for all those organizations who is working on that one to adopt that security into the DevOps part.
Great points. So Abhishek, 80% of all the software out there has got open source. We've been talking about open source off and on yesterday and now today, even in our discussion. Any lessons learned how to best manage open source risks?
Yeah. So I'll again probably share my experience, what has worked for me at the scale that I have seen. So if you consider, as Matt mentioned, that 80% of software in any application comes from open source, right? So that means whatever risks are there, vulnerabilities are there in your application, in addition to that, you are inheriting the risks, the vulnerabilities from all the third-party applications or third-party dependencies that you have, right? So for me, if I'm starting a new project today, I would probably adopt tools like, say, dependency check, or maybe commercial tools like Black Duck or Snyk to start building a gate, security gate right from day one, where you cannot ship an application with high or maybe critical vulnerabilities in third-party dependencies, right? But that is probably not ideal. Most of us have lots of legacy applications or applications where we have not implemented the gates, right? In such case, what has worked for me, or what I would suggest based on my experience, is that probably we should start by implementing the detective control side of things. Adopt the same set of tools, scan this application maybe as part of the CI or on a nightly basis, build some dashboard where it gives you a visibility of your software bill of materials across all your projects, all the vulnerabilities that you are inheriting by adopting those third-party libraries, as well as maybe the licensing related things if that's relevant for you. What has worked for me also, like showing this dashboard to the respective teams, maybe the engineering managers or the directors, and have them take action. Just get their commitment that we will reduce or remove only the critical and high risk vulnerabilities, right? So that is probably a stepping stone that will lead us to a baseline of hygiene, as well as drive a culture of shared security responsibility, where the teams are responsible for, the various teams are responsible for the security of their own software components, right? Once a certain baseline is reached that most of the applications do not have high or critical vulnerabilities in their third-party dependency, that is a place where we should probably bring in some preventive controls, which prevents introduction of new high-end critical vulnerability, so that this system or this baseline that you have achieved with some hard work is maintained, right? Otherwise, what will happen is that, again, this will get polluted. New vulnerabilities will come in. Great point.
Yeah, managing your backlog is a big challenge if you don't already start some process to clean it up. So, part of what we've been talking about is really talking about and dealing with developers and development communities. And one of the things that comes up a lot is about the resistance to perform, the cyber work at the right time, or, hey, I've got to get this delivered. If it stows, it goes, and we've got to, we have to make this release this week, and so tends to have cybersecurity done at the last minute or sometimes being cut off. And, to me, it goes back to around the accountability. A lot of what accountability is dealt with today in most companies is at the developer level around vulnerabilities. They don't think of it as, it's a transactional activity. It's like, okay, hey, you needed to do this task, or you needed to perform this, or hey, you've got 6 criticals in your process or your product, your software. And what I want you to think about is a slightly different view. And that is, accountability for software isn't just your job. It's your boss's boss's boss, all the way up to the owner of the company, right? Because at the end of the day, it's their product. And if you think this way and build a culture of that, you actually will get a more universal adoption of cybersecurity in your company. One of the simplest ways is driving that accountability so that the development managers and CTOs all understand that your work as a developer, they're responsible for it. And a great example where I've come from is we have a program that we've established that says, hey, the CTO signs off on every release of software. And when the CTO is the person signing off on the software, you can be assured the developer is not going to hand up bad code. Well, they might do it once, but there's surely not going to be a second time. And it drives a level of maturity, and it drives a level of diligence into the quality of software. And more importantly, it drives a whole cultural mindset of this is important. It's quality. It's part of what we should be delivering. So just think about that as you implement your own programs. How can you drive that accountability further up into the organization? So want to jump into Mrudul. From one vendor to another, let's jump into software supply chain risk. How would you combat that?
Yeah, so I think some of the points Abhishek already mentioned, so I'll try to have some additional one. So everybody's aware of today's software supply chain, right? When you build any software, there are a lot of dependencies because not everything you have in your control, right? From infrastructure, there are binaries, then you have third party, open source, as well as I think build tools and so on. So the code that you write, it depends on a lot of things in the ecosystem, and that's where the supply chain comes. And because you have many components and dependencies, of course there is a risk, because if any component goes rogue or any component is exploited, the entire chain is exploited. And we have seen the example, I think the one which Abhishek mentioned, SolarWinds, right? Because if that was exploited, all the organizations using that tool got actually at a risk. Now, how to combat that? So 3 points I was thinking about. One, definitely there has to be a continuous open source or third-party library scanning that you should have in your organization. And we should not wait for external researchers to come back with a CV now, because that is the case right now. It's a very reactive approach. And we saw the example in Log4j, Spring4 Shell, all of these examples we saw, and they were like a foundational libraries in your code. Only when external researchers showed those CV, I think it's a turmoil for everyone to fix it. That should not be the case. I think that's a very reactive approach. So there has to be a frequency-based kind of a scan in your system where you can look at all these different systems or sites we have. MITRE is one. A lot of industry-based tools where they continuously look at the industry patterns and cyber attacks, and they have that data, what is exploitable in the industry, what are the new attack vectors. So learn from that. Have the pointers from that and evolve your own scanning program with DAST, where you implement those simulations and start scanning all the open source libraries in your ecosystem, in your company. So before external researchers can come back with a CV, you have some idea. You basically will find out some exploitation in your system. So that is one. Second, we talked about dependency. Right? How do we know the dependency tracker? So nowadays, all the tools, Sonatype is one, where it gives you the complete SBOM, the software bill of materials. So complete dependency checks and tracker of the binary that you're using. So you know where it can go wrong and what you have to sanitize. So use that. And the third one is integrity of the entities that you use, and that goes right from, if you're using container, the image of the container, which is like a self-contained application, from that to the binary and to any artifact that you could have, right? So make sure all the artifacts right from the assessment is done and you're ready to deploy. How you can make sure the integrity of that before you actually deploy. So there are a lot of new concepts are coming from signing, verification, and the Solar Shield. So things like that I think you should implement. So there are many ways to combat, and now all organizations should be on this in terms of how do we make sure there is no software supply chain risk. And it's a difficult problem to solve. It's not one or two ways to do that, but we should get on things like this.
Great points. Great points. So, kind of our last question in here, but I want to sort of very quickly throw out to you guys is, what are the best practices every cybersecurity program should have? So we've talked about the process. Now we're going to talk a little bit about the program. So, and I'll start off with, one of the things I tell people who don't have a program or just starting out is, right, you should have an incident response program, what we call PSER, Product Security Incident Response. And by the way, that is very different than a typical IT, incident response or other types of incident response programs in your company. The difference, probably the most significant, is that you're interacting with an external third party, right? Could be, India CERT that we're here today. It could be a number of different researchers, and that's a very different type of conversation than, hey, I've got a ticket, my server's down, and the whole relationship is important, and it's quite different. More of the point in larger context here is that you need to have a way for your customers and other people to tell you have a problem. And if you don't have some sort of an instant process that's published and public, how would anyone know? So just a thought, have an incident response program. So Harish, what do you got?
From my point, security awareness is most important. Right now, it's a most important, I can say, for every organizations. We should have a security awareness program because we are talking about the software security, and developers, definitely they don't have a security backgrounds from the beginning itself, but yes, they are learning, they are using the tools and all. So the awareness about the security across the organizations, including the developers, non-security guys, so it will aware them, okay, there is something going on in the world, so how you can prevent and how you can save yourself, because attacks happen. So in phishing, you can say that the targets the easy guys. So when you send okay, this kind of phishing is happening, these are awareness you share with the organization employees. So they know, okay, these kind of things can happen in the organizations, and they learn from them and they implement, and they can save yourself and the organization as well.
Great point. Mrudul?
Yeah, so I'm just going to talk about a program which is well known, but it's again next gen, defense in depth, because today hackers are one step ahead. They're always, probably, unless we think like them. So there is, and they use a lot of different technologies, tools, and so on, and different methodologies, and we never try before we come to know from them, right? So there is no silver bullet for any technology for us to combat that, or even one single layer. So that's why we need to have a multi-layer strategy for defense. And it was there, just that I think the layers have increased and how you do that defense has changed. So right from the network layer to the data, there are different defense in depth you can do. You can have the network security at the application layer 7. You can have WAF, web application security, then IDS, IPS switches you have. Now, what has changed, or what we should put more focus is, now there is, the era has gone where network security was enough. Now the attacks have reached to the code level, right? So application security has become more important, and that's why it should evolve and it should change, and we should put more focus in terms of how we do application security. And there is a concept about not trusting every entity even in the same zone. So the concept about micro-segmentation, right? Lateral movement has to be stopped. So in a particular zone, when you have different entities, you have to trust each entity after you verify, though it is a software entity. You cannot trust different binaries in the same zone. So lateral movement, micro-segmentation, that is a new change in the defense in depth in a particular layer, which is the application layer, where you deploy different system components. Another layer is a data layer, because data is at core, and now data becomes structured, unstructured, both. Structured data we are always used to protect in terms of databases or the directory servers that we use with different levels of encryption. Unstructured data sometimes get unnoticed, like your files and emails and the shares that you have, the shared data, right? So there has to be focus for data protection for unstructured data as well, because data is at the core. And that defense is definitely required in terms of defense of depth. Other thing I just wanted to mention is we have to definitely go from detecting and responding to now with this behavioral patterns feedback loop, from predicting and then protecting. And that's where we will become more efficient.
Great. Abhishek, take us home.
What was the question again? Can you repeat?
So the question was really about what are the best practices a program should have?
Is it application security program or
Yeah,
security
so
program?
security architecture, that sort of thing.
Yeah, okay. So if I'm responsible for the defensive side of things, then probably for me the most important bit is don't get hacked. Okay, so do whatever is required to prevent the attackers. But talking about that, if you look at it, there is a very famous saying. I think I saw this some 12 years back in some conference. Is that there's a quote. Defenders thinks in list and attackers thinks in graph, right? If you just recollect what all things we have been discussing, right? We have been discussing lists, this. Attackers will not care any of that, right? Attackers will try to discover everything that you have from their experience and their expertise. They will find the attack surface which is most important or where they have the most expertise. Doesn't matter where it comes into the defender's priority, and they'll just use that, right? So that's how it works. Attackers, that's why there is a saying, attackers will always win. Because of this, I would say information, asymmetry between defenders. Defenders' work is much more difficult. Attackers just need one attack surface and one area where they are good at. Defenders needs to be good at everything and know about all the attack surface. Talking about attack surface, if I have to look at from that perspective, I would say, threat modeling or security architecture review is an important part of the overall security program, right? When you are building a system, before the engineering aspects of it starts, if there is a collaboration between the security team and the engineering architects, if the architecture of the system is reviewed, formal threat modeling process is performed, mostly you will identify a lot of threats very early in the SDLC, right? Whether that involves maybe slightly re-architecting the system to reduce attack surface. From my perspective, attack surface reduction is the most important bit.
Great point.
Your defense, as a defender, your job is extremely difficult trying to protect against every single attack surface. So as a goal, I would see how to reduce attack surface as much as possible.
Great point. Well, we've got about 1 or 2 more minutes and wanted to see if anybody had any questions. Go ahead.
Hey, hi, this is Anil from Carrier Corporation. So I just have one question where we are facing day-to-day challenges. It's like you are talking about the open source component which we are using. See, the problem is our product is in the market from last 10 years and we are consuming open source component very properly and we are doing all check from Black Duck. Now the problem is the components which we are consuming have not been updated from last 4 to 5 years on the GitHub repo. Now we left with 2 options. Either we download and develop that particular open source component and consume it, but there'll be a license challenge, there'll be a lot of things. Second thing is either we go for another open source component which is similar features, but that will impact a product which is already there on the field. So wanted to see what is your opinion on that.
So this is the exact reason why I said supply chain security is very complex. So just by running dependency check or Black Duck and all these things, it's not enough. The problem that you are facing, most organizations are facing, this is the unmaintained software. You are dependent on external components which are not maintained anymore. So in some cases, if you're lucky, if it's some very popular component, there can be some organizations who commercially maintains that. But in other cases, from what I understand or based on my experience, there is no other way but have a strategy to either replace that component with internally developed behavior, similar behavior, or replace that with a more mature software component. This is exactly the reason why supply chain security is not just about vulnerability. It's also about having the control where you can vulnerability is just one of the attributes. If you can somehow detect and deny the inflow of third-party components which are not approved as per your security policy. For example, as a developer, it is easier for me, it is the path of least friction for me to find a library which does my job today. I will not care whether that library will be maintained 3 years or 5 years down the line. But as the security team, if you have that right set of controls, and if you can deny that if a software component is not matured enough, or if it is not supported by, say, any of the major open source bodies like, say, Apache Software Foundation or maybe Google or some of those well-maintained libraries, then those are not approved. Or maybe you can look at a case-to-case basis, look at it and approve. Once it goes inside, it is extremely difficult to remove it. It has a major impact.
Great. So with that, I think we're kind of at time. And what I would say, we're going to stick around. So if you guys have any questions, come up and talk to us. I, again, want to thank everybody for coming out and seeing our session. And again, thank you all, panelists, for coming out. Thanks, everybody.